Hi everybody. Today we are going to see one of the fundamental concepts of physics. But before we are going to see what exactly we are going to deal with, I would like to just give a brief introduction about what we are exactly going to see. I hope you would have come across a very famous scientist named Sir Isaac Newton. So he was one of the famous English physicists come mathematician who lived in the 17th century. And as you all know, he was famous for defining one of the fundamental forces to which we all are subjected to. Of course, each and every matter on this earth is subjected to, which we call as gravity. And of course, he found that there is a force which is pulling every body on this earth towards its center, and that he understood from the basic phenomenon of an apple falling from a tree. Since he was a scientist, he could give a little more in-depth analysis to that, and he totally thought the falling of an apple in an entirely different dimension. If there is a ball, and assume that this is of course a body, and if I am throwing it up, it gradually comes down. So what is that which attracts this towards the center of the earth? And this also applies if I am going to jump, I am going to fall back again. So every body on this earth is subjected to gravity. So based on this particular force, Newton, he has postulated several mathematical equations to actually determine the effect of force and the impact of force that is creating in any body which is subjected to our study. And these equations is what we collectively call as Newton's laws of motion. And these equations, they form the very basic assumption or the very basic criteria in all our designs, in all our applications that we are going today. Right from a small nail being hammered till the launch of a rocket, we have Newton's laws everywhere. And today, in this session, we are going to deal with one of the fundamental laws of motion, which is Newton's second law of motion. So, without a pen and a paper, we cannot understand it with intricate details. So, let's go to the study board. In this session, we are going to deal with Newton's second law of motion. So what does Newton's second law of motion exactly state in mathematical relation? It states that force equals mass times acceleration. So before going in detail about what does this exactly say, we need to know what is acceleration, what is mass, and what is a force. And of course we know that force is defined in Newton's first law of motion. So force is considered to be an agent of change. If there is a body which is moving like this at some constant velocity, it continues to move in a straight line unless acted upon by an external force. So every body continues to be in a state of rest or uniform motion unless acted upon by an external force is what is told by Newton's first law. So what does this mean? Of course, we have neglected the resistance due to air and other frictional resistances offered to this particular body moving. So if there is no frictional resistance or air resistance, then this particular body will be moving in a straight line unless and until it is acted upon by some force which deflects its path. So force is basically considered to be an agent of change. Now, what is mass? So mass is defined as the total summation of the individual masses of particles constituting a body. Now take this ball. This ball is made of numerous tiny particles. So this ball is basically an assemblage of particles. And each particle has its own mass. So it feels a little heavy in lifting each particle. So the total masses of individual particles which is constituting this particular ball is going to be the total mass of this ball. Then we are going with acceleration. But before going with acceleration, we need to know what velocity is. Velocity, v. So what is velocity? Velocity is defined as the ratio between displacement by time, and it has its units meters per second. Now, having defined what is velocity, we are defining what is speed. Is speed and velocity same? Are they equal? No, definitely not. Then what is speed? Speed is defined as the ratio between distance traveled to the time taken in traveling that distance. And like velocity, it also has the same unit of measurement, which is meters per second. So what is the basic difference between speed and velocity? Velocity is measured in terms of displacement, whereas speed is measured in distance of distance. So what is displacement and distance? So there is a very simple example. You have a pendulum which is in its mean position. Now you are just oscillating the pendulum to one direction, and after some time t, the pendulum would have reached this position. So now the pendulum has traced this curve here. So if you are zooming this thing, the curve goes like this. So this mean position is point A, and the final position I have marked as point B. Now what is displacement between these 2 points? The displacement is the least distance between any given 2 points. So this is displacement. Whereas distance is the actual path traced between any given 2 points in space. So the length of this arc forms the distance. And displacement, there is a significant difference between displacement and distance, where displacement is a vector quantity, whereas distance is a scalar quantity. So since displacement is a vector, velocity is also a vector, whereas speed is not a vector, rather it is a scalar. So having defined what is velocity, we are going with acceleration. Now acceleration A is defined as the change in velocity by time. Like if a body is moving at some velocity, for example, you take a car, and this car is initially moving at 5 meters per second. Now after some time t, which is after 2 seconds, it has gained its velocity to be around 10 meters per second. Now what is acceleration? Change in velocity, that is 10 meters per second minus 5 meters per second by time taken is 2. So the acceleration comes to be around 2.5 meters per second square. So this is basics of what is velocity, speed and acceleration. Now how this comes in terms of Newton's second law of motion. Now, having defined that force is mass times acceleration, this particular equation is applicable in many practical applications. But we can also read this equation in a different form. Like, we know that the acceleration is defined as the change in velocity with respect to time. So what is this v and u? V is the final velocity attained by any body, and u is the initial velocity. And this change in velocity, that is from initial velocity to final velocity with respect to time, is what we define as acceleration. And I have also given you a basic example of a car moving at two different speeds in a given time period, and we also calculate what is the acceleration. Now, this equation is written in this form. So I can multiply this mass inward, and this becomes mv minus mu whole divided by t. Now, this form of the Newton's second law has a very practical significance, that it is used right from hammering a nail till the launching of a rocket. This is one of the fundamental equations which is used in almost every engineering application today. Before going in detail about what this equation exactly says, we have to define a term called as momentum. So momentum, there are two types of momentum. One is the linear momentum and the other is the angular momentum. But now, for this scope of the session, we will define only what is linear momentum. And the linear momentum is nothing but the product of mass times velocity of any given body. So where this momentum plays a very important role, and what is it actually? Like, if you take a ball, or you can consider it as a bullet, and this bullet has a very small mass m, but if it is fired at a greater velocity v, then you will feel a net impact to be much higher, and that impact is what we call as momentum, which is nothing but this mass of this bullet times the velocity v. Since velocity is a vector quantity, momentum is also a vector quantity. So momentum is based on its magnitude and its direction, and it is very important to consider the direction of application of momentum. So now, having known what exactly momentum is, I can read this Newton's second law of motion as the force is equal to the rate of change of momentum with respect to time. Now, this equation is what we are going to deal with, one of the very simplest practical examples. So, force is defined as the change in momentum with respect to time. Now let's see a practical example of what this equation exactly says. If I have a ball and this ball is dropped from a height, so this ball has a mass m, and this ball is dropped from a height where its velocity is v, and here I have a bat. Okay, just assume that this is a bat, and this ball comes with a velocity v. It strikes this bat, and again it travels at a straight path just opposite to the path what it has traveled before. So here again the same ball is going up to a different height at a different velocity, and that velocity I will assume as v2, and the same mass is going up. So in this case, now the velocity at which the ball comes down is v1, and after striking the bat, the ball goes up at a velocity v2, whereas the mass of the ball remains same. Now this bat is giving a force to this ball, because as you can see, the initial momentum of this ball is m times v1 and the final momentum, that is now here in this study, the final momentum is after striking the bat, the ball again goes up. Now since I said momentum is a vector quantity, the sign convention is also very important. If I am considering the downward momentum to be positive, then the upward momentum should be considered negative. So here the initial momentum is downward, so it is positive, whereas the final momentum of this ball is negative mass times v2. So if I am writing this in this form, then I can write as the force given by the bat can be calculated knowing the change in momentum, that is minus mv2 minus, because this is the final momentum, minus mv1, which is the initial momentum, by, let us assume the bat has struck the ball in 0.2 seconds. So knowing these values, I can estimate what is the force that has acted over the ball due to this bat. So this is the significance of this Newton's second law of motion. Now the same equation is also used to find what is the force which is acting in a rocket when the exhaust gases comes out at a tremendous velocity, and we know what is the mass flow rate of exhaust gas which is coming out from the rocket. So we can estimate what will be the upward force which is acting due to this change in momentum of this gas. And the same Newton's law is also applicable to estimate if there is a hammer and there is a nail, and this nail is to be struck into a wood, then knowing the time period of contact of this hammer over this nail and knowing the momentum, the initial and final momentum of this hammer, we can estimate what force would have acted on this nail to prick it into this wooden board. So in so many applications, whatever we have seen, this particular equation has played a very fundamental role. And this equation also gives rise to a new term called as impulse. So what is impulse? It is nothing but F into t, which is equal to the change in momentum. So all the practical examples what we saw now is an example of impulse. That is a huge amount of force acting in a very small instant of time is what we define as impulse. And rocket, this hammer and nail, and the ball which is struck by a bat is all examples of impulse. And here, not only these applications, in many similar applications, this impulse is playing a very significant role. And this is what is another dimension of Newton's second law of motion. So I hope you would have understood the basic significance and the application of this Newton's second law of motion. Thank you.